Hello everyone, my name is Alan Hubbard and I am a junior studying industrial engineering here at Clemson University. Being an industrial engineering student, I aspire to land a job in which I can optimize various processes. A great example of such a job would be one involving the medical industry, in which optimization of workflow, diagnostic testing, and client communication would be mandatory for any company's success. Although it may not seem like it, such a job would require use of material science concepts to solve various engineering problems. Medical laboratories that participate in diagnostic testing commonly practice histology, which is the study of microscopic anatomy of tissues and cells. Like many practices in the medical field, analyzing these tissues for diagnostic testing is a process in itself, which can be observed and subsequently optimized. Although there are many variations of the process depending on the type of the test being performed, there is a basic formula for examining tissues. According to a manual of laboratory and diagnostic tests, the formula consists of extracting a specimen, dehydrating the specimen so that it can be cut into thin sections, embedding the specimen into a mold using materials such as paraffin wax, cutting the specimen into thin sections using a microtome, and finally, staining the resulting thin sections so that they can be viewed under a microscope. Each step of the process is truly amazing, but for this video we'll be focusing on the steps that involve paraffin wax and how it relates to materials science. Paraffin wax is a multi-phase material that is commonly used throughout the process of histology. According to the Encyclopedia of Chemical Processing and Design, it is typically colorless, although sometimes white, and consists of a mixture of hydrocarbon molecules. Although solid at room temperature, the material has a melting point at around 40 degrees Celsius and is a great electrical insulator. Along with its high resistivity, paraffin wax is good at storing heat with a specific heat capacity of 2.14 to 2.9 joules per gram degree Celsius. Its ability to change from a liquid phase to a solid phase relatively easily is what makes it so useful. As an example, let's say we want to calculate the amount of heat energy required to change a 5-gram sample of paraffin wax from being in a solid state at room temperature, 23 degrees Celsius, to being in a liquid state at 60 degrees Celsius. Using the formula Q equals mc delta T, where Q is equal to the heat energy, m is equal to the mass of the sample, C is equal to the specific heat, and delta T is equal to the change in temperature, we can compute the following. As a result, we can see that the required heat energy to create this specific change from a solid phase to a liquid phase is 395.9 joules. So why is paraffin wax and all of its properties important as a part of the histology process in medical laboratories? Paraffin wax itself is key in efficiently preparing tissue specimens to be cut into thin sections and examined. After dehydrating the specimen and clearing it in an organic solvent, it is placed in a concentration of paraffin wax in its liquid phase. The paraffin wax and the specimen combined are then left to cool for a number of hours until they reach a solid phase. This is relatively easy as paraffin wax is in its solid phase at room temperature, allowing for laboratory technicians to work with the specimen under normal conditions. Once the tissue specimen and paraffin wax solidify, they can be cut into thin sections using a microtome and prepared to be stained and put under slides. Given its lack of color, paraffin wax does not affect the view of the specimen slides under the microscope, making it exceptionally useful. As an aspiring industrial engineer, I hope to one day have a job in which I can optimize processes within the medical industry. As there is always room for improvement in laboratory practices, processes such as preparing a specimen to be viewed under a microscope can be optimized to increase performance and reduce turnaround time for clients awaiting results on clinical trials and medical diagnostic testing. Being aware of the various materials used in the laboratory, such as paraffin wax, and applying my knowledge of material science concepts will hopefully allow me to be successful in my future endeavors at an aspirational job. A true challenge involving the paraffin wax would be finding the most optimal conditions for its use, such as the amount of material used at a time and its ideal solid phase and liquid phase temperatures, and applying these conditions to be practically and efficiently used in the medical industry. Hopefully, I can find the optimal solution to this currently used method and solve many other engineering problems as I continue my professional development. Thank you for watching.